The following data is the average cost of a fast food meal on a Friday afternoon. Use Excel to find the mean and standard deviation. So we have 12 values here. I put those 12 values in a vertical line, and I'm going to use that to find the mean and the standard deviation. Now, to find the mean, I'm going to use formulas, and the mean is a statistical formula, so I need to go to More Functions, Statistical, and to the average. Now, I want the average of these 12 values, so I click on the top one, and it's the cell A1, and I drag all the way down to cell A12. When I see that up here, A1 to A12, I click OK, and my average is 322,833. Well, we're talking about money here. So I'm going to go back to the home screen on Excel, and you see these buttons right here that I'm circling. I can click those, and it will go down to whatever decimal value I want, or I can go bigger if I go the other direction. But because I'm going with money, I want to go to the nearest hundredth, 2 decimal places. So I have my mean, $3.23. Now, my standard deviation, again, formulas, more functions, because I need statistical functions, and I'm going to go all the way down to the S's where I see standard deviation, stat dev. Now I'm going to use the S because we are dealing with a sample of fast food meals on a Friday afternoon. I'm pretty sure there are more than 12. So again, I'm going to click and drag. I want to highlight these 12 values from A1 to A12, and I'm going to click OK. So my standard deviation, again, I go back to the main screen where I have these decimals, and I'm going to move it down to just be 2 decimal places, so $1.46. So I have found the mean and the standard deviation. Now, there is a second part to this question, and it says, use the empirical rule to answer the following question. What is the probability of a person paying more than $4.69? Express your answer to 4 decimal places. Now, if you think about the empirical rule, I'm going to try to do this as best I can here. We know that the mean is in the middle, and that is $3.23. Now, if I go to the right 1 decimal place, I would add $1.46. So that would be $4.69. So the thing is, what's the probability of a person paying more than that? Okay, well, the percentages, if you draw your vertical line, through your mean, we know between 323 and 469, that is 34%, right? So we're looking everybody to the right. Okay, this is kind of hard to do in Excel because I don't just have like a drawing function, I don't think. No, I don't think I do. Okay, so who is to the right? Well, we know that everybody to the left of the mean is 50%, right? Because the mean splits it directly in half. And we know that between the mean and the first one standard deviation to the right is 34%. So that's how much is to the left of 469, and we need everything to the right because it says more than $4.67. So if 84% is to the left, how much is to the right? Well, if you take 100%, oops, forgot the 100% and subtract 84%, well, that leaves you with, let me go one more spot here, 16%. Now, it says express your answer to 4 decimal places. So I change that percent to a decimal, and I have 0.1600. Now, you could just put 0.16. I don't know if it'll be picky about the zeros or not, but 16% of our people will probably pay more than $4.69 based on the empirical rule and the data that we are given.